this video here is going to cover two parts. We're going to cover bisecting any angle. I'm going to do both an obtuse angle and an acute angle. You'll see it's identical, it's the same thing between the two, but I'm just going to show you both. So first up here, I'm just going to draw any obtuse angle. So if I just start anywhere, I'll just draw a line out there, and then I'll just create some kind of obtuse angle. Maybe not that steep, maybe just a little less. Okay. So there is my obtuse angle. Obtuse angle just means any angle greater than 90. And of course, completing the 180 here, this would be a supplementary angle. All right, because the two angles adding up to 180 would be the angle and the supplementary angle to that angle. So to bisect this angle, all I have to do, and it's the same principles as if we're bisecting a straight line essentially, except maybe we're given the point to start, which is right here. So I want to bisect between these two lines right at this point. So what I'm going to do is just set my compass up to a radius that will work. Okay? You don't have to be too specific. As you do this more and more, you'll just get more comfortable with what you need to do. So now if I cut that or draw an arc with this as my focal point, my center point for the compass, I'm going to create 2 points here. Let's just call this C and D. Now what I want to do now is basically I have created a straight line between C and D that is providing this center point right in the center. So basically I have an imaginary line now drawn from C to D, which essentially I want to bisect. I already have this point here. So now I'm going to set my compass up to be about 3/4 of the distance from CD. And then I'm going to scribe an arc out above this point, approximately where I think the middle is going to be. And then I move the compass point over to C, and I draw another arc. So now, when I take my straight edge, and I connect from my center point here, right through the intersection of these two arcs, now I have two angles that are identical. So I have cut this obtuse angle perfectly in half. Now the reason this works, let's get a different color here, is essentially by creating these distances the same. So this distance from this center point here to C is the same distance as the center point to D. Sorry, so the same distance from the center point to C is the same distance as the center point to P. Now, if I were to just draw, I'm just going to do a hidden line type of line here. If I were to draw a line across these 2 points, essentially what I've created is a straight line between points C and D, where I'm going to put a perpendicular right through. Because remember, these two are the same length, which means this forms that part of the isosceles triangle. So now if I create an isosceles triangle on the other side, which is what I've done when I created these two arcs, now when they meet, I connect those through, perfectly cutting CD in half right to the center point, or the converging point of our obtuse angle, which means now we have a perfect bisection of this obtuse angle. Now I'm going to do the same thing with an acute angle. So I'm just going to start here. I'm going to draw this one somewhere out here. I should do this in black. My apologies. So I draw a straight line out here, and then from this, I just create any acute angle. Okay, so any acute angle. And any acute angle just means it's less than 90 degrees. So between these two angles here, this angle is less than 90 degrees. This is an acute angle. Now, if you were to form this up to form the 90-degree angle, the remaining angle past this acute angle would be a complementary angle to complete the 90 degrees. So we'd have the angle and then a complementary angle to see the 90. Whereas the obtuse, we would have the angle which is greater than 90, and then we have the supplementary angle to make up the rest of the 180. Okay, but that's more in your book there, so you always have that if you want to know. But when we bisect this, we're going to do the exact same thing. So I'm just going to set up a convenient radius, something that works. I just set up on this converging point here of this acute triangle, or acute angle, and I just scribe an arc that cuts through both sides of this angle. Right? So it cuts through here and it cuts through here. Now, from these 2 points, I'm going to set my compass point on this one. Again, let's just label these quick. So let's say this is C and this is D. So from D, I'm going to take my compass. Now realistically, for the best X you can get, you want to set your compass up to be about, sorry, I'm moving my paper here. You want the compass to be set about 3/4 of the way between the line you're bisecting. And here I'm actually bisecting CD, right? So for the best X, I want to set my compass up to be about 3/4 of the distance between C and D. Now that I have that set, I draw an arc away, and then I go from C, so the compass point's now on C, and I draw another arc. Now just for visual, that's a little tight, so I'm just going to come back to D and just draw that a little bit longer, just so you can see the exact conversion point between those 2 points. All right? So now I can take my straight edge right to the conversion point and then draw a line straight through where they intersect. And that is now a bisection, creating 2 equal angles from that acute angle. Now, of course, this is the exact same thing we did with the obtuse angle, and the exact same theory applies. If I were to draw a dotted line between C and D, these are the same distance away from our center point here. So that means the distance from O to D is the same length as the distance from O to C, which, thinking back to straight lines previously that we did last week, we have an an isosceles triangle right here. Then we just created another isosceles triangle, and I'll just draw this one in just so we see it. From there and there. Even though those radiuses are different, as explained in previous videos, this is still now an isosceles triangle, this length here equaling this length here. Because these 2 are equal, they create the isosceles triangle, which now, if we have 2 isosceles triangles and we drop a line connecting the center points, or the apex of both of these isosceles triangles, it will bisect this line. And this line forms the arc distance between CD, which then will bisect this angle, CD. It'll cut it directly in half. And that is the bisection of an acute angle, which is the exact same theory of bisecting an obtuse angle. They are identical.